Hello everyone, my name is Arthur. I'm a PhD student at the University of Kent in England, and I'm here to talk about something that has nothing to do with my research, which is language servers. More specifically, I wanted to showcase why languages like Haskell are good candidates to implement your language server in. So the goal of this talk is to learn about LSP development. LSP stands for the Language Server Protocol, but I'll be using the term as an umbrella word to also talk about language servers. The first half of the talk will be an introduction to language servers, their features, their flow, how they work, and then I'll also go into the protocol itself. The second half will showcase the actual code of an LSP that I implemented in Haskell a couple of months ago. I'll also explain how I tested the language server, and then I'll quickly tap into the implementation of LSP clients. So a quick bit of history. The language server protocol is actually quite recent. It was developed in 2016 by Microsoft, and it's widely adopted now, obviously in VS Code, but also in NeoVim if you use the LSP configuration plugin. It's also available on IntelliJ IDEs, but it's not the first candidate for language support because they still push their own thing, obviously. And as in any protocol, data is exchanged between senders and recipients. In the context of LSP, we'll be talking about server, which will be the language servers, and the client, which is usually the IDE. Just to make sure that everyone's on the same page, the language servers are the tooling, the bridges between this language tooling and IDEs. Language tooling include linters, compilers, code formatters, and in this era of LLMs, code generators. So what do LSPs actually do? Well, they provide these red squiggles that you must be familiar with. We call them diagnostics. The LSP also provides hovering information when you put your mouse over something. It can provide like additional information on the symbol you're hovering. It can provide code actions to perform a certain task on your source file. It provides auto-completion, inline suggestions, as well as going to the definition of a symbol, getting the references of a symbol, and it can also allow you to rename the symbols. It also provides syntax coloring in some cases, code formatting, and the LSP server can also send messages, which are usually error messages, so you don't really want to see them. So how does it all come together with your IDE? Well, let's say you're on your computer and you're about to start your favorite IDE. Depending on the file that you're opening, it will trigger some kind of IDE extension. In the case of the LSP, it will be also an LSP client. This LSP client will connect to an LSP server, and it will either send a request and expend some kind of response from the server. This happens when, for example, you put your mouse over something. Or when you send, the LSP client can send an event to the server, but in that case, the server doesn't have to answer anything. It's just an event, and the server can behave as it wants. This happens, for example, when you open, close, or save a file, and the LSP server can also send data asynchronously, for example, diagnostics. I said earlier that the client's connected to the server, but it can happen in multiple ways. Usually what happens is that when the client starts up, so when you open a file in your IDE, it connects to an LSP server. Usually it spawns the server, but sometimes it can just connect to an instance that's already running in the background, either on your local machine or over the network, because it's a JSON-based protocol, so it can definitely happen on an external machine. Once the client knows where the LSP server is, it will send an initialize request, and the server will send back a list of capabilities. That's because the LSP protocol has so many events and requests that's possible. This list of capabilities allows the server to filter out the events and requests not to send to the server to avoid any useless message passing. And then the client sends an initialized event. And once this event is sent, this client and the server can start working together. So as we saw before, the client can send events or requests, and the server can send back responses. So the capabilities is the main point of the language server protocol, and according to the documentation, there are 3 kinds of capabilities. The most important one, the most obvious one, is the language features. So it's the one that we saw earlier. Anything that's related to symbol management, hovering, getting code actions, syntax coloring, etc. But it's also about file management and document synchronization. So it's whenever the user closes, opens, or saves a file. And there's also the workspace management, so anything that's related to the file system. So anything that happens when the user creates, deletes, or renames the file. This is all documented in the LSP documentation. This is the QR code to the web page online. It's actually just a single page, but there's so many information that it can be a bit hard to navigate. It lists every single feature that's supported by the protocol, and for each one of them, the documentation provides a description of the feature, it tells whether it's a request or an event, and it provides a documentation of all the payloads that are involved with any feature. For example, what happens when you put a mouse over a symbol in your IDE? Well, this is what happens. It triggers a hover request, and the documentation says that the hover request is sent from the client to the server to request hover information at a given text position. So we learned 2 things from this. The first one is that it's a request, so the recipient will have to send back something, and that it's sent from the client to the server. Depending on the event, sometimes it's the other way around. This is the kind of data that the client will send to the server. It's basically a text document position parameter along with a work done progress parameter. Basically, it's a file URI, a cursor position, so a row and a column, and a cancellation token. And the server will send back this object, which is the hover object, which basically contains the string that will be printed in the IDE in the hover bubble. Fun fact is that it actually supports Markdown, so you can include media like videos and pictures. So now, let's see what an LSP server looks like. So for context, at the school I graduated from, we had this linter, this coding style checker for Haskell code. So you'd have to call a CLI tool to actually check whether the linter had like warnings to give you or not. It had like 3 levels of warnings: info, minor, and major. And the worse the coding, mistake was, the lower your grade will be. So this was important. Unfortunately, we didn't have any LSP integration for that, so I just decided to develop one. Since there are so many events that the LSP server would have to handle, even though there is only one user of the IDE, there would be some kind of state management and concurrency handling. The state would basically store the diagnostic that have been reported by the linter. And so it will be implemented in Haskell using the LSP and LSP types libraries. The LSP library is basically the network layer that's responsible for receiving the information from the client and sending data back to the client. And the LSP types is a auto-generated library from a JSON specification of the protocol. So it's always up to date. However, it is a bit hard to navigate because since it's auto-generated, there's no documentation within the code itself. So you have to cross-reference the code from the LSP types libraries with the protocol documentation to actually understand what data you have to use with the LSP libraries. This is actually quite important to know because LSP types is not just a poorly documented library, it's just an auto-generated one. And once you know that, it makes it a bit easier to use. So this is what the entry point of the LSP server looks like. There are 3 things that are interesting here. The first one is this doInitialize callback, which will be run when the server receives the initialize request. Here it's pretty simple. It just sets up the internal state of the application. Then we have the static handlers variable, which is basically the list of all the features that our LSP server will be able to handle. And finally, we have this text document synchronization option, which will be sent back to the client after the initialized request. Here we just specify that we want to receive any event that's related to the text documents, whenever you open, close, or save a file. Because even though you declare the endpoints to actually handle these events, if you don't specify these options, you won't receive the events. And I did lose at least a couple of hours not understanding why I did not receive the events, even though I had the endpoints implemented. So, good thing to note. This is what the list of the event handlers look like. It's pretty simple. You can grow it very easily. And for each one of these, it just handles one event or request of the LSP protocol. For example, what would happen when you delete a file in your IDE? Well, on the top of my head, there's not that much that you would need to do, aside from maybe removing the potential diagnostic that you had for these deleted files, and you would want to remove them from the internal state. Well, actually, so this is the code of the deletion notification handler. So it's just a notification. We don't have to send anything back to the server. So from the notification payload, we retrieve the URIs of the deleted files, and we delete them. We delete the diagnostics of these files in the state. And then, for each one of these files, you publish an empty list of diagnostics, which is a bit weird, and I don't know if it's a bug from VS Code, or something that's not specified in the documentation, but at least NeoVim does support this. But if you delete a file in VS Code, the diagnostics will still show up. So to clear them and to flush them, you have to send the IDE back an empty list of diagnostics for each one of them. It is a bit weird. Another example is when the client requests diagnostics for a given file. So it's quite similar to what we just saw, except that here it's a request handler, so we have to send something back. The request comes with a payload which contains the URI of the file that we want to get the diagnostics of. And for that, we use the internal state to see if we had already called the linter on that file. And if we did, we just return it. Otherwise, we would call the linter by hand, pass the output, put it in the state, and send it back with the publish diagnostics function, which comes from the LSP library. So once again, it's very straightforward. You don't have to think too much about the underlying technology and the network communication. Now, testing. We all are good software engineer here, I hope. So of course, you have to mention testing. Thankfully, the people who implemented the LSP library and LSP types library also came up with the LSP test library, which allows you to test your LSP server. Basically, it allows you to send events, requests, and test what diagnostics and code action it will return to you. So, for example, if we had this file, this one, it's quite simple, but there are actually 3 coding style errors according to the linter here. The first one is on line 3, because the myPutAcr function doesn't have any type definition. Second one, the too many ifs, has too many nested ifs. And the third one is actually quite unique to the school, because they request us to provide a header at the beginning of each file that we submit. So this is what we would expect the IDE to look like. We would have 2 major coding style issues, which are the red ones, and a warning one, which is the yellow one. So using the HSpec library, we can set up an LSP session and send an event to the LSP server saying that, hey, I opened that file, the one that we saw earlier. And then we wait for the diagnostics to be published by the server, which is the wait for diagnostics function, which is very handy. It gives back the list of diagnostics that were emitted, and using the usual HSpec utilities, We check the number of diagnostics that we got, and then for each one of them, we can check more information. For example, we check that the first one is indeed a warning, and we test the error message that comes with it. That's it, really straightforward. A quick note on LSP clients, because once you have your LSP server developed, you want your users to be able to use it with their favorite IDE. So regarding VS Code, you have to write this TypeScript application using a framework provided by Microsoft. So it is around 170 lines of code, excluding the usual dozen of configuration file that comes with any TypeScript project. And once the application is ready, you have to publish it on the Microsoft Extension Marketplace using an Azure account, which, if you're not familiar with the entire Microsoft ecosystem, can be a bit of a pain. But it is possible, and it is free, by the way. But on the other hand, if you are using NeoVim with the LSP config plugin, you can just add an entry to the configuration in your file. And it's just around 10 lines of code. I know the comparison is a bit unfair here, but I just wanted to showcase how easy it was to do that on NeoVim versus on VS Code. So, as a conclusion, we saw that the language server protocol was quite complete. It provides loads of features, so it kind of requires the server to be implemented in a declarative way, because the server has to declare which capabilities it handles. So it's kind of behaving like a web server with like endpoints and stuff. So it feels like a declarative implementation approach is the best one to use here. That's it. I think we have time for questions.
Thank you for that. Do we have a question? Yep.
Yeah, so I know that, oh, my seat. So Vim subsumed a lot of NeoVim features after it came out. So does it need to be NeoVim, or can it be the more recent Vim? I'm not sure if there are more recent ones after.
I haven't used Vim. I've only been using NeoVim quite recently, so I'm not familiar with how it works.
Okay.
But I think there should be a bit more configuration to do here, because I don't know what the support for the LSP on NeoVim itself is.
Okay, and the initialization block that you showed, does that run asynchronously? Because one of the great things about Vim is that it opens instantly, and I wouldn't want to not have that.
I don't think it's supposed to, because the server has to send back a response to that initialized request once it's ready. So if it's asynchronous, the client might start sending you events that you might not be able to handle if the state is not ready. So I think it's supposed to be synchronous. It is allowed to take some time, because if you have, like, I don't know, external servers that you rely on, you can definitely wait for them to be ready, but you should wait for them and send the response to the request once it's ready.
Great, thank you, great talk.
I think there's one more question. Pavel, do you want to ask a question?
Hi. So I joined late, so I couldn't really see the beginning of the talk, but so my question is probably answered already. But the libraries that you've used, both the LSP and Haskell and the LSP types, was it also something you've written, or was that already on Hackett?
No, it already existed. It is a great piece of work, and I was really glad it existed, because otherwise I wouldn't have implemented it in Haskell.
Gotcha. So overall, by the way, amazing presentation, like, appealing to me human eyes. It's really great. I loved it. Question is, the experience that you had writing this, how hard for it's like overall, if you were to grade it, how hard the experience was to write something for a completely new language, the LSP server. Was it like a pleasant experience, or were there a lot of hoops in between?
It was relatively easy, aside from the few pitfalls that I had. For example, this one, when I did not understand why I did not get these open, close, and save events. The documentation is quite clear, but there is a lot of stuff to read, and I mainly use other implementations of language servers using that library to understand how it worked. But overall, it was really relatively easy and satisfying to do because you get the results on your IDE. No, it was a quite fluid experience.
And second quick question, the agentic tools, the AI tools, they do pretty well work with things are documented. If there is a protocol at hand, they tend to sort of survive in that environment, the writing complex system. Did you try using one of those, or you were just writing everything by hand?
No. I did not. I've never played with AI-based LSPs, but I guess they should use something that's similar. Aside from maybe the fact that
I don't know. My question was, did you support your work with AI tooling, or did you just write everything by hand?
Did I use
Yes.
AI? Oh,
yeah.
no,
Okay.
I never do.
Cool. All right. Thank you very much.